In this tutorial, we are going to learn how to construct a confidence interval for a population proportion. So before we get into how to do this in StatCrunch, let's take a moment and discuss why we're actually creating a confidence interval for this value. So let's consider the state of Illinois and all registered voters in the state of Illinois. We want to know what proportion or what percentage of the voters agree with pension reform, since that's a big topic right now considering our budget issues in the state of Illinois. It would be very difficult to survey every single registered voter in Illinois, and even if it was possible, it would take a lot of time and a lot of resources. So instead of surveying everyone, what we do is we only survey a portion of the registered voters in Illinois. Thus, we have a sample, and we try to figure out what that sample tells us about the population. So in other words, the population proportion is unknown. We're going to take a sample, which will produce a sample proportion, and we want to know how well that does in estimating our population proportion. So let's consider the example I have over here on the right. It says we want to construct a confidence interval of the population proportion at the given level of confidence. So it tells us that x is equal to 126, and so in this case, x represents the number of individuals in the sample with the specified characteristic with which we're looking. In our case, we could say that we have 126 registered Illinois voters who favor pension reform, but that's out of a total of 210 registered voters who were sampled. So again, we decided to sample 210 voters. Of those 210 voters, 126 of them said that they favor pension reform. Using this data, we want to construct a 90% confidence interval for the population proportion. So our first step is to calculate our point estimate, which is our sample proportion, or the notation for that is p hat. So p hat is going to be 126 divided by 210, which gives us 60%. In other words, 60% of the surveyed voters said they favored pension reform. Now here's the thing, even though our sample, we had 60% favor pension reform, the likelihood that that value, meaning 60%, is the same as what it would be if we surveyed everyone is very small. In other words, there's a very, very small chance that p hat and p would be the same value. This is why we need to construct a confidence interval. So instead of reporting one number, we're going to report a range of numbers that we believe the population proportion to fall within. Before we can proceed with that though, after we calculate p hat, which we found to be 60%, we need to verify two conditions to make sure that our p hat distribution is going to be a normal distribution and that we have independence in between our values. So the normality condition is that n times p hat times 1 minus p hat is greater than or equal to 10. This should look familiar from chapter 8 when you studied the characteristics of the p hat distribution. This is what had to be satisfied in order for that distribution to be normal. So in our case, we sampled 210. Of those 210, 0.6 favored pension reform, which means 0.4 did not favor pension reform. And when we multiply that out, we get 50.4. Since 50.4 is definitely greater than or equal to 10, that means we have satisfied the normality condition for our example. We also have the independence condition. The independence condition says that the sample size should be no larger than 5% of the population size. In symbols, that means that lowercase n is less than or equal to 0.05 times uppercase n, where lowercase n is your sample size and uppercase n is your population size. We know our sample size is 210. We want that to be less than or equal to 5% of our population size. In our case, the population would be the total number of registered voters in Illinois. I don't know what that number is, but I am confident that if I were to take 5% of it, 210 would be less than that. In our class, we kind of will fudge on this a little bit and just make sure that it seems reasonable that our sample size is less than or no more than 5% of our population size, because we'll rarely know the exact population size. But in practice, it is definitely something that we want to consider. Okay, so once you've calculated your p-hat or your sample proportion, and once you have verified your normality condition and your independence condition are met, then we want to use StatCrunch to proceed with calculating the confidence interval. So now I'm going to go over into my empty StatCrunch spreadsheet, and I'm going to click on Stat. Then I'm going to choose Proportion Stats because we're working with a proportion. We are going to choose one sample because we are only dealing with one sample. There is the option for 2 samples. However, we do not cover 2 samples in this class, so you only have to worry with the first one. And here's where you want to be careful. You have 3 choices here. We're only going to be dealing with the first 2. You can either choose with data or you can choose with summary. With data would be if I actually had a column of values in my spreadsheet of yeses and nos on whether the registered voter believed in or supported pension reform. If you don't have a column of yeses and nos, all you have are counts, which in this case we know that 126 said yes. That is called with summary. So you really want to pay attention to whether you have the actual data, that would be a column in your spreadsheet, or if you have summary, which is just a count. For the homework, you're going to be dealing with summary. When you go to do Project 3 Part 2, you will be needing to use with data. Right, so I'm going to choose with summary, and you'll see that our one sample proportion summary dialog box appears. The first thing it asks us is for the number of successes. In our case, the number of successes is 126. Then it asks for the number of observations, which in this case, that's our sample size, so 210. Now it asks us what you want to perform. You have 2 options. You can perform a hypothesis test. That is what we will be doing in Chapter 10. But here in Chapter 9, we are wanting to construct a confidence interval. So I'm going to click on the radio button next to confidence interval for P. Then you want to enter in what is your level of confidence. This will always be stated in your problem. You will not have to come up with that on your own. So if we look over to the right, it tells us we want a 90% confidence level. So that means my level is going to be 0.90. Then we're going to click on Compute. There's several things we want to note in our results dialog box here. All right, it does tell us that we have computed a 90% confidence interval for a proportion P. So our count was 126 out of 210, so that just verifies we entered in the right information. If we were doing this with data, then this would be a quick way to get our count. You never are expected to count that by hand, right? It shows us that our sample proportion is 0.6, which verifies our p-hat value over here in step 1 was correct. The next value it gives us is the standard error. That is the standard deviation of the p-hat distribution as you learn to calculate in Chapter 8. But what we're really focused on right now are these last 2 values, the lower limit and the upper limit. This is our confidence interval. So we can see that the lower limit on our confidence interval is 0.544, so rounding that's roughly 54%, and our upper limit is 0.656. If we round, we would say that's roughly 66%. So we can say with 90% confidence that the population proportion of Illinois registered voters who support pension reform is between 54% and 66%. When you enter this into MyStatLab, it will simply ask you for the lower limit and the upper limit, or it will ask you to enter the limits, in which case you would enter both of them separated by a comma. Please understand that when we say we are 90% confident that the population proportion is between 54% and 66%, we are not saying there is a 90% chance the value is in there, because it is either in there or it is not. To say that we are 90% confident means that if we were to take, let's say for example, 100 different samples and compute a confidence interval for each one of those samples, so we would have 100 confidence intervals, then 90% of those 100, or 90 of them, would actually get the true population proportion and 10 of them would be wrong. I have highlighted some passages in the textbook with push pins that you really want to focus on in terms of the interpretation of these confidence intervals, because that's a place where students often will struggle. Also note that in this particular problem, I have specifically told you the value of x, the value of n, but typically you're going to be doing word problems, and so that's information that you're going to have to identify as you're reading through the problem. The last thing I want to take a moment to go over with you is just quickly to show you what it looks like if you're going to do a confidence interval with data instead of with summary, since you will be responsible for doing that in your Project 3 Part 2. So I'm going to go to a different screen in my web browser here. So you'll see I've pulled up the Elementary Stats Spring 2015 survey data. This is the survey that I conducted in my stats class last semester of all the questions students wrote themselves, just like you did for Project 3. I have uploaded this data set into our group page so that you have access to it if you want to try and recreate what I'm doing here. All right, so what I want to do is focus on gender. Right? And I want to create a confidence interval for the population proportion of males who took the survey. Okay, so I'm going to click on Stat, then I'm going to go to Proportion Stats. I'm going to choose one sample, but in this case, because I have a column of responses, I don't have a count. I'm going to choose With Data. Now you'll notice that this dialog box looks slightly different. So the first thing you have to tell it is, where is my data stored? Well, we're working with gender, so I'm going to click on gender. Then you have to identify what is a success to you. What is it that you are looking for in creating your confidence interval? Well, I had said we want to create a confidence interval for the population proportion of males. So my success is going to be a male. Now, you want to be careful here, because you have to type in this response exactly as people responded in the survey, meaning they responded not M, but male, and it has to be capitalized. Otherwise, this will not work correctly. Then I'm going to click on confidence interval. We'll stick with the 95% confidence interval this time, since I'm just demonstrating to you what it means to do a confidence interval with data. I click compute. And we will see here that in our survey that we did last semester, 63 respondents were male out of a total of 312. If we do 63 divided by 312, that will give us our p-hat, which tells us right here our p-hat is 0.2. We do need to verify our two conditions, which is our normality condition and our independence condition, just to make sure that this confidence interval is valid. If you take 312 times 0.2 times 0.8, I'm rounding a little bit there, you will get roughly 49.92, which is definitely greater than or equal to 10, so we're good there. And 312 should be less than 5% of all males, so we're good there as well. So our lower limit is approximately 16% or 0.16. Our upper limit is approximately 0.25 or 25%. So we would estimate that the population proportion of males with 95% confidence is between 16% and 25%.